Hey, everybody. We did this in class today, and I think that several people were a little bit confused because we hadn't seen it in a problem format. So I'm going to go over these so that mom and dad will know what we did in class today. So Diego wrote the number 7,653. Which expression has the same value as the number Diego wrote? The way I want the kids to solve this problem is this. I want them to say, here's a 7 in the thousands place. So it can't be A because that's 70,000. So it can't be A. Could it be this one? No, because that's 700. 7,000 right there. So my guess is it can't be this one either. So let's see if the rest of them are correct. 650 and 3. So we know that C is the best answer. Number 2, Melanie wrote a number in expanded notation as shown below. 3 times 10,000 plus 5 times 1,000 plus 2 times 10 plus 7 times 1. What number did Melanie write? Well, we're going to look for a 3 in the 10,000s place. This has a 3 in the thousands place, so it can't be that one. 3 in the 10,000s, yes. 3 in the 10,000s, yes. 3 in the 10,000s. So none of those could be eliminated. So now we're going to go to the thousands. We have a 5 in the thousands place. Yes, we do. We have a 5 in the thousands place, a 5 in the thousands place, and a 5 in the thousands place. So we didn't eliminate anything on that one. So now 2 in the tens place. Do I have a 2 in the tens place? Yes. Do I have a 2 in the tens place? No. Do I have a 2 in the tens place? No. So I think this is my answer because 7 times 1, 7 in the ones place? Yes, 7 in the ones place. So G is the best answer. Now this is what we did today. This was kind of new. Wyatt wrote 44,444, then labeled the digits J, K, L, M, and N as shown below, blah, 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 blah. The value of the L right here is 10 times greater than the value of which other letter? Well, we learned today that this is 10 times greater than that, and this is 10 times greater than that. So we're saying that this is a times 10 situation. So M, it's 10 times bigger than M. So M is the best answer. There's only going to be one of those on the test. That's really a 4th grade skill. We're just kind of introducing it in 3rd grade. So it's not that intimidating. We're not going to spend a whole lot of time on it. It comes with understanding the place value system. So number 4, which represents 50,197. And just like the others, I have a 5 in the 10,000s. Well, these all have a 5 in the 10,000s. So 50,000 is good for all of them. But then any thousands? I don't have any thousands, so it can't be this one. And then I don't have any thousands there. So 100, there's a 100. There's a 100, but this has a 10, so that doesn't work. Can't do that one. So we've got a 100 and 100. Now I'm going to go to 90, 90, and this one only has a 9, so it can't be this one. So now we've eliminated everything but this top one. 50,197. Number 5, which number is composed of exactly 8 10,000s, 400s, and 3 ones? And like I told them in class today, I would always, always, always suggest making a place value chart and using it. Ones, tens, hundreds, and then ones, tens, hundreds. Because when they give you a question like this, they are going to have you put it in the place value chart, and then you're just going to put zeros every place that you didn't put a number. So you're going to have 8 10,000s. You're going to have 400s and 3 ones. So I'm going to put zeros everywhere else. So I'm looking for 80,403. And looky there, it's D. I scribbled all over it, but it's right there. Okay, place value chart is going to be the best way to get a question like that correct. Then working on the opposite side, Keisha wrote a 5-digit number and circled the digit as shown. And this is almost exactly like what we did in our notebooks today. Which other digit in the number has a value that is exactly 10 times the value of the circled digit? We did that today in class. We know that if we go left, it's going to be times 10. I kind of wrote it weird, but there you go. So it's the 6. And we also talked about how just moving left or right doesn't change it. The digits actually have to be the same in order for that to be a true statement. The times 10 has to be, the digits have to be the same for that to be a true statement. Number 2 on this side, shaming is thinking of a 5-digit number. The number has a 7 in the hundreds place, a 5 in the tens place, and a 6 in the thousands place. Shaming could be thinking of which number. It's a lot like the number 5 we did down here. I'm going to do a place value chart. Ones, tens, hundreds, ones, tens, hundreds. Sorry, I wrote all over it again. I'm writing backwards, but that's how we do it in a place value chart. So, and they didn't even give them to us in order this time. So it's a 7 in the hundreds place, a 5 in the tens place, and a 6 in the thousands place, 1000s place. And it says it's a 5-digit number. So we know that there's going to be a number here and there's going to be a number here, but we just don't know what it is. So we're looking for a 6 in the thousands place. This one does not have a 6 in the thousands place, so it can't be that one. This has a 6 in the thousands place. This has a 6 in the thousands place. This has a 6 in the thousands place. So all those could be it. And we're looking for a 7 in the hundreds place. There's a 7 in the hundreds place, a 7 in the hundreds place. Oop, there's a 3 in the hundreds place, so it can't be J. So then I'm going to go to my tens place, and I'm looking for a 5 in the tens place. Oops, that has a 3 in the tens place. Ha, that has a 5 in the tens place. So we know it can't be that one. It must be this one. So did you have to do this? Not necessarily, but it did help me. You could just do it from the problem, but I just like the idea of using a place value chart. So number 3, which shows 90,492 written in expanded notation. So how many 10,000s do I have? 9. So 9 times 10,000, sure. 9 times 10,000, sure. 9 times 10,000, 9 times 1,000, nope, cannot be. So then we're going to go to the next digit that's represented. That's a 4 in the hundreds place. So 4 groups of 100, sure. 4 groups of 1,000, nope, can't do it. 4 times 100, sure. 8 times 10, sure. 8 times 100, nope. And then lastly, 2 times 1. So A is our best answer. These questions generally aren't that bad. The kids don't have that much trouble with them. But they do have to look at every single digit, and they don't always do that. And they have to make sure they're in the right place. Now, this is a pictorial model. So all they had to do was say 1, 2, 3, 4, 5, 6 10,000s, and 1, 2, 3, 4, 5, 6, 7, 8, 9 thousands, 1, 200s, 1, 2, 3, 4, 5, 6 tens, and 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. So we're looking for 69,269. 69,200, oops, 69, sorry. That was the kicker right there. Okay, so it just had to match. All they had to do was count them up. That's called a pictorial representation, or a pictorial form, or a picture form. Anything that's giving them a model for them to identify. Now on this page, this was wackadoo. Again, it's just a different way to do it in a picture form. So they had to group the 10,000s. They had to group the thousands. They had to group the tens and the ones and the hundreds. I don't know why they're written in weird order, but we said that there were 1, 2, 3, 4 10,000s. 1, 2, 3, 4, 5 10,000. Excuse me, 4 10,000s, 5,000s. There were 1, 2, 3, 4 hundreds, 2 tens, and 1, 1. On this one, just because I thought it was easier, we started with the ones place. And we were looking for anything that had a 1 in the ones place. So this has a 1 in the ones place. This has a 1 in the ones place. This has a 1 in the 1 in the ones place. This does not. So we eliminated 1 right away. Then we went to our tens place. We're looking for 2 in the tens place. Yep, yep, yep. Can't eliminate anything. So go to my hundreds place. I need a 4 in the hundreds place. Yep. Nope. Yep. So then I'm going to go to my, where am I? I'm going 10,000s now. No, I'm going thousands, sorry. 5. I'm looking for a 5. Yep. No. So it can't be that one. It has to be this one. Did it take me a while? Yes. Was it hard? No. We just took a while to do it. And if they take the steps that I took, they can do it too. Step 2, Samira and Tanika wrote 4-digit numbers. Samira wrote 8,754. Tanika wrote 4,839. The value of the 8 in Samira's number is how many times greater than the value of the 8 in Tanika's number? Well, we're only in 3rd grade, we're only talking about 10 times the number. So we learned today that if you move to the thousands place, that's times 10, and that's in the thousands place, so we know it's times 10. We didn't do anything times 100 or times 1,000. So that one should be pretty easy, but it's kind of a new concept. Number 3, which shows 63,015 written in expanded form. So I'm looking for 6 times 10,000, 6 times 10,000, 6 times 10,000, 6 times 1,000. No way. 6 times 10,000. So I can't eliminate any of the others. I'm looking for 3 groups of 1,000. Sure, sure, nope. Then I'm looking for 1 in the tens place. So 1 group of 10, not 15 groups of 10. That's silly. So it can't be that one. But this has 1 group of 10s and 5 groups of 1. So that is the correct answer. So our elimination worked. And number 4, which number means the same as 5 10,000s plus 3,000s plus 7 10s plus 6 1s? So that's just another way, it's kind of like a cross between word form and expanded notation. So we're looking for something that has 5 10,000s, which is 50,000, right? Plus 3,000s is 53,000. So we're looking for 53,000. 7 10s, 6 1s, 7 10s, 6 1s, and then 0 there. Again, 1s, 10s, hundreds, 1s, 10s, hundreds. And if you do this, you have 5 10,000s, you have 3,000s, 7 10s, oops, I squished it, and 6 1s. That's going to be easier to do. Easier than what I did. So 53,076, 53,076. Once they have the number written, it's easy to figure out what it is in word form. So moving on, we have 4 more to go. Hopefully I can get this done before the vacuuming starts. So number 1 on this side says, Miss Hilton drove her truck 17,809 miles last year, which has the same value as 17,809. Well, it's going to be 1 times 10,000, which is 10,000, 7 in the thousands place, 8 in the hundreds place, 9 in the ones place. This one was super easy because it was A. This was 100,000s. This was a 10,000, 7,000, 800, and then 90. So that one was eliminated right here. This one was 1,000, so it couldn't be it because it had to be 10,000. So A was definitely the correct answer. Now 2 says, which shows 20,202 as a sum. They could just add them up. They know how to do that. They could go 2 plus 2 is 4, and they go, no, that doesn't equal. And they could go 0 plus 0 plus 0 plus 1 plus, that's 2. And then all those zeros is 0. And then all those zeros is still 0. So that can't be it. And then all these zeros don't add up to 2. So that can't be it. Or you could do this one, 0, 0, 0, 0, 0, and you get a 2, and you get 0, 0, 0, 0, 0, 0 plus 0 is 0, 0, 0 plus 1 plus 1 plus is 2, 0 plus 0 is 0, 1 plus 1 is 2. Or you could do, which one shows two 10,000s? There's one, there's two 10,000s. Which one shows 200s? There's 100, 200. Which one shows two ones? 1 and 2. So either way gets you to the same answer. We found out that J was the best answer. So either way, if you can disprove, that's one way to eliminate, or you could just do the place value. But two ways solve the same problem. Number 3, Fernando wrote a number in expanded notation as shown below. 7 groups of 10,000 plus 3 groups of 100 plus 5 groups of 10. Which number did Fernando write? 70. This is going to be 70,000 and then 310. Oh no, 50, sorry. 350. It's been a long day. So 70,350, which was D. Sorry, I flubbed up on that one. And then finally, Chelsea wrote the 5-digit number shown below, 36,622. Which statement is true? They had to read on this one. They didn't want to read. They all picked F. And that was very much incorrect because the value of the 6 in the thousands place is 1,000 times the value of the 6 in the hundreds place. It is not. It's only 10 times. Like I told them today, we've only learned 10 times anything, so this can't be it. The value of the 6 in the hundreds place is 100 times bigger. No, we haven't done 100 times anything, so that can't be it. We learned today that the most we can do is the one right next door is 10 times more. So the value of the 2 in the tens place, boom, is 10 times the value of the 2 in the ones place. We learned that if we move from this place to this place, that's multiplying by 10. So that one is true. Ew, sorry, H is true. The value of the 2 is 1. And then they did it in the backwards order on J. Okay, so that is what we did today in class. It's the first time we've really applied it like this. We've done a whole lot of like stuff in class, but we haven't applied it. And tomorrow they have a quiz. So, and we're hoping to take it as a major grade on place value. So it's going to look very much like this. So I would suggest that you guys familiarize yourselves with how to work these kind of problems. And then tomorrow's going to be a piece of cake. Thanks for watching. Bye.